for you guys if you don't mind. Let me minimize this here and go ahead, turn the light off. Okay, the building that we had, the 10,000 square foot building that you guys had with your friend Chad, part of the requirement was to design a generator to back up the building. The NEC code book guys have three types of emergency system or three types of backup system for the building, classified accordingly. Emergency system, people's life depend on it, the most important system you're going to encounter. And then legally required standby system. This is also very important, required for the safety of the people too, but not as important as emergency. And then optional standby system, which is like Dunwoody wants to put a generator here so we can continue our operation as a business. Three types of system that you can install in any building. These are the guys, the code refers to them as Article 701, Article 702, and Article 7, I'm sorry, this is 700, this is 701, and this is 702. Three different articles, the NEC refers to them separately. The difference really is very clear. The difference is emergency system, people's life depend on it. A good example of this is in public areas lighting system, people panic. When they panic, they could, you know, as you panic, you could endanger your life or other people's life. So that's light, emergency light isn't an emergency exit signs and emergency lights and egress lights are emergency system. If you have a riser, I believe fourth floor or more, that requires you to put one of your elevator on the emergency circuit because you need to be able to move the people fast. So these are emergency system. If you have a hospital, the operating room, the patient room, these all have to be an emergency system, right? People's life depend on it. The only difference, guys, like I said, this one have to come up within 10 seconds. 10 seconds. Within 10 seconds, your emergency light, your exit signs are better, but emergency light have to come and fully operate within 10 seconds. Legally required standby system, they give you 60 seconds. 60 seconds. These are like a sump pump. If I have a sump pump and I don't put it on a backup system and it malfunctions, you lose power, what's going to happen to your basement? It's going to flood. So it's required in public areas, also related to safety, but not as important. The second tier of safety, put it this way. So you can put them on that one. Jails, you have certain things in lights in the jails, locks, operator 911 operating stations, police stations, all these places that are required by law to have a backup generator, but they're not. They have to come up within not 10 seconds, within 60 seconds. The last one, guys, the optional. This is done with the College of Technology or the business that you're working on or Chad's backyard. Through a generator, you lose power whenever you finish your cup of coffee and you feel like turning that power on, you can go there and turn it. Any question about these three different distinct systems that you can have?
I thought it was if you had any elevator, only get that, it's only one story in there.
If what?
If you have an elevator at all, you need a...
You know what? I don't want to even open the height. There's a lot of rules about the height. But on risers, you have to put one elevator or two, depending where you are, on a legally required standby system or an emergency system. So that will coordination with the architects and so forth. Escape routes and so forth. But if it's required to be, here's what we do. When we build the riser, we coordinate with the architects and the builders and all this stuff. And if that particular, for escape or whatever, if it's required to be an emergency system, what do? We throw it in our emergency system. That's already exists. Any comments, guys? Any questions about these three distinct systems? Okay, so what we need to do, so the first thing we'll talk about, understand emergency system, legally required standby system, and optional. I can't emphasize the word optional standby system. By the way, Kerry, my friend, the generator that we designed for this building, you guys designed it for me, and you came up, what size, Jeff? Was it 200 kW or 300 kW? 200 kW. Our 200 kW generator, 200 kW gen that we sized at 208/120 volt, 3 phase, Anybody can tell me what type of, where does this generator fit in the three systems? Optional. Is it emergency? It could be. It could be emergency. The reason why it's not emergency, because Jeff, remember we had bug eyes? Remember that bug eyes that you guys installed? That's our emergency system in the building. We decided to use bug eyes as an emergency system. Then is it legally required? I don't have anything required by law to have it. I already have in my emergency system. I don't have in a commercial building. I don't have anything required by law to be on a legally required standby system, locks or whatever. Then the only system is optional because we want business continuity. We want business continuity. Any question, guys, about the 20 kW generator that we sized? Was not an emergency system. We decided it's going to be an optional system. So does it have to come up within 10 seconds or 60 seconds? Typically it will, because we have an auto transfer switch, but it doesn't have to. The reason why it doesn't have to, because in our building, we bought bug eyes. You guys remember that bug eyes? These are the bug eyes that we did, and there's batteries inside them. So that's my emergency system, localized emergency system. Okay, the second thing, guys, is select and size the generator. You have already done this one with your friend Chad. We have common software that we selected and size the generator. Select, we decided to use diesel engine, right? Remember that? Diesel engine, voltage 208, 120 because of the system that we have, and we picked all the loads based on the type of the load, light, or HVAC equipment or motors, and based on the electrical current of these equipments, a starting current and a running current, we size our big fat 200 kW generator. Can I have thumbs up, Chad? We fully understand how we did that one. So that just talks about, this chapter talks a little bit how to do it by hand, which is find the full load, the running kVA of the equipment, full load current multiplied by by voltage by 1.73, add them all up in one side. On the other side, you take the starting current of the equipment, and then you go find yourself a generator that's capable of running Brian and starting Jamie, for example. So running the load and starting the big chunk of load. So that's what this talks about, guys. Understand how to connect typical emergency. Then we have connecting typical emergency system to the power supply. That will be emergency feeders and branch circuits. Here's my question for you, gentlemen. Can I put my emergency branch circuits and feeders in the same conduit with non-emergency branch circuits and feeders? No. So that's very, very important. When you have a branch circuit, emergency branch circuit, or feeder, it has to be completely separated, box-wise and conduit-wise and cable-wise from any other system. Here's another question for you, Darren, my friend. If you have a legally required standby system, not an emergency, legally required standby system, sump pump in the basement of Dunwoody has a generator. The feeder going to that sump pump is coming from the generator, and one coming from the one from the gen and one from the service going to that pump to an auto transfer switch. Can I put the legally required standby branch circuit or feeder in the same box or conduit with the normal power? Anybody can help, Darren? Not emergency, legally required. Well, if it's an emergency, no. If it's legally required, yes. That's the major difference, guys, between legally required system and emergency system. Now, who cares, my friend Andrew? Because when you guys doing takeoff for your project and you have an emergency system, Jeff, my friend, you have to allocate different conduit system to your emergency system. Legally required standby system, you can use the same conduit system to carry them. Is that a big deal or not? It is a big deal, so you can use it. Not like it's a good idea, though. If you ask me, being engineers, it's nice to have the conduit separated for the whole system, since they're coming from different panels anyway. So these are the stuff that we're going to do. Understand requirement for transfer switches. With every generator, guys, come auto transfer switch or manual transfer switch, and there's also static transfer switch. There's all these three transfer switches that you can do. There's three transfer switches. This is the auto. The one that we designed is called auto transfer switch. Manual transfer switch, that's manual. You walk in and you flip that circuit, right? You manual walk in and flip to one side or the other, right? Easy. So that the name implies auto, start by itself from a signal from the control system. When you lose the power, since there is no power, send the signal to the gen, start up, the gen starts, synchronize, come up to speed, flip the load into the generator when you lose power. Any question, guys, about the auto transfer switch? Piece of cake. Uh, Manual transfer switch. Chad lost power in his house because the storm hit the distribution line. He was eating breakfast with his kids. He finished the breakfast it took him an hour because he eats a lot. And then after he finished, he goes and start the generator and flip the auto transfer switch, the manual switch. Does that make sense? Static transfer switch. This particular one, guys, these guys, they don't get you static. They use them a lot in electronic equipment. These guys are even faster than the auto transfer switch. They don't, when they flip, they don't give you any, like auto transfer switch, when you transfer, you lose momentarily for a second, the light will dim, will disappear and come back. You lose the light, just momentary. That's for auto. For static transfer switch, you wouldn't even know that you're in generator. You would not, they go so fast and close transition, they close to the utility before they add the generator, so you don't see any flip in the power system. Any question, guys, about these three types? What we did for our project, Jeremy, my friend, is not this one. We use the auto transfer switch. Any comments, any questions, guys, about this? Comments, questions? So that's what we use in our project. When it comes to the emergency, guys, like I said, there are three articles dear to your heart as you move forward. These are the three very important articles that you're going to be dealing with. Emergency system, 700, Article 700. In this article, it will tell you it has to come up within 10 seconds. Number one, it has to be separated from any other system, right? In that one, it has to have separated from any other system. It will tell you what type of backup power, batteries, generator, wind, that you can use as an emergency system. It will tell you have to have, for your generator, you have to have an alarm that alarms if your generator is working, not working, so annunciating panel. So that's all an emergency system. Legally required standby system, same thing, guys. It will tell you 60 seconds here, and it will tell you no separation between the two systems in conduits. Everybody understand the separation? When you say separation between branch circuits and feeders, no separation. If it's legally required, separation if it's emergency. Optional standby system here, whenever. You can start it whenever, right? And it will tell you also no separation. I can put my branch circuits from the generator and the utility in the same conduit. Not a good idea, but in the same conduit. And it will tell you no separation. And for these, you need the auto transfer switch. Also tells you auto transfer switch here. You need manual transfer switch or auto transfer switch. So the first two must auto. The second one optional. Does that make sense? You can typically use a manual. Okay, so these are the most important articles. Any comments, any questions about this? Comments, questions?
If the static is so quicker, wouldn't you want a static on the emergency system? Just
Expenses. Money.
But for like hospitals where people on life support might not be able to afford that 10-second lag or whatever they use.
What they do for the hospitals, when they in the operation room, they also the operating machine has a backup batteries on them. So they come up with like the machines and the light in the operating room. Somebody's laid on the operating room. They have two systems actually. They have bug eyes sitting there that when you lose power, momentarily it shines power on that open chest while the generator is coming to speed. And also the equipment that drills into your body. These are also backed up by the machine has a backup batteries. So, and then for remember, 10 seconds only. You're only covering 10 seconds. After 10 seconds, bam, or you'd hope the generator will happen. I was teaching a code class, guys, and there's a couple of guys in the East Coast, and they were telling me when, what's the name of the last storm that hit? Stacy? Sandy, thank you. Sandy, I keep mixing them. Sandy, when Sandy came, all these generators that they have for hospitals, they're on the lower level. And what happened if you're on the lower level? You flooded. So you have a hospital with a beautiful generator flooded and can't work. So they were saying is there's a major reevaluating or where you put your generator for an emergency generators. So if you put it in a basement, as we typically do, or outdoor, and you flood, good luck. I mean, here's the hospital, 10-story hospital, and a stupid generator in the basement is flooded, but the hospital is okay at the second level and above, right? So they're reevaluating now where do you put these generators for in a flooded zone. So anyway, so that's a good option. Some people put it on the roof. The challenge with the roof is you have to have a crane, but yeah, some hospital put them on the roof. And and also the other challenge, Adam, is generators vibrate and they're heavy. So when you put them on the roof, then you have I'm not saying it's not doable. It's a challenge. You have to design structurally. You have to design your roof to handle the weight and the vibration coming out of that generator. Which a lot of buildings, when we go Boston Scientific right here, Weaver Lake Road, that's by your neck of the wood. Is that Weaver Lake and 494?
That's where I live.
You live there? Yeah, we're going to be visiting Boston Scientific. When we go there, they have a gen on the fourth or the fifth floor on the roof right there. So it's great. If you flood, there's not like it's going to flood that area, but you're in good shape.
Now, if your emergency system has to be separated in your required standby, why would that not have to be separated?
The standby,
Yeah.
because it's not as important.
But
You
if
can.
it's required,
Yeah.
you would think it'd be,
If it's you mean legally required?
yeah.
Is not at there's the urgent and the important. The urgent is the emergency. The important is the legal required. Now, does it mean now, Jamie, my friend, that's what the code says. Now, you as a designer always separate them. It's a good idea to separate them. Do you see what I mean? We did it in the hospitals. We always separate them. You know, that's what the code requires. The code is the bare minimum. The code is the 70, pass on and move on. Like Chad would always say, get your 70 and move on. That's the code. If you want to get your A, you're going to go higher than the code and separate all these systems. Does that make sense, guys? The code is always the bare minimum. Okay, in healthcare facilities, guys, the healthcare facilities, a lot of the healthcare facilities is emergency system, and they divide it into critical life safety. So there's emergency critical life safety. So they divide that, they go drill deeper into the like a patient operation room. That's life safety, and this have to have a backup batteries plus generators. So they go deeper. If you have the luxury of working in a hospital, you will have to separate your power system into first emergency system, non-emergency. Then the emergency will be separated in critical, life safety, the essential, non-essential, and then the essential will be safety, life safety, and critical. And there's another and equipment. So they separate them even deeper, which means you still have 10 seconds, but they have batteries backup for certain areas too. Okay, after Katrina, we still get Katrina's, guys, and 911, 9/11, the NEC code in cycle 2015 came up with an article 708. 708 came directly after Katrina 911, 9/11. And this is critical, they call it critical operation power system. This system is the government will decide that for security reasons, social security, military, whatever you want to call it, financial security, food chain security of the nation, Now we're talking about government. Certain buildings have to have a backup power exactly like, not emergency, not legally, not optional, not healthcare, backup power of the whole building or major part of the building, because these, if you interrupt the flow of business in these buildings, it will create a disaster for the nation. So that's a government. So for example, federal bank could be qualified like this one. Hospitals, already emergency systems, government buildings, certain part of the government buildings, so they continue to run the operation. Certain food chain distributors that distribute food for the nation, that could qualify. And so if you qualify as this, then they call it hubs. Then you have to have a backup generator to back up not only the light and the receptacles, so you basically have to get in business. continue to run your business. Any question guys about the critical operation power system? Who select which one is going to be critical? Government. For business continuity, because of impact on the security, the food security, the national security, these buildings have to be completely backed up, or part of it is going to be backed up. By the way, Aaron, this is the only place in the NDC code book where they required to have security system for the building because of terrorists and all this good stuff. You have to have monitored security system. So it's really interesting. Came after 2005. Okay, any comments, any questions, guys? So our building that you did with your friend Chad, we were right in here. We decided we're going to use optional backup system because we want to run the office building not 24/7 if we lose power. Any comments, any questions? Comments, questions about that? Okay, there's a couple of other codes that related to what we do, guys. Healthcare facilities, there's another code. These are FYI that will tell you how do you do an emergency system in a healthcare facility. Go deeper than the code. They call it standard for healthcare facilities. There's also life safety, the legally required standby system. NFPA 101 life safety will tell you which load need to be on the life safety, which is legally required or emergency. So that's another article, just FYI. And this one, 1010, standards for emergency and stand power systems. If you have a generator, how often you're going to maintain it, troubleshoot it, place it, and all this good stuff? They add it here. And if that's not enough for you, we have IEEE, guys. I don't know if you saw that a couple of weeks ago when I was printing things. These are all IEEE standards. There's another standard called recommended practice for emergency and standby power systems for industrial application. So that gets into more and more details. Everybody understand, guys, in the electrical industry, there is thousands of documents. NEC code book is only one of them. So as you go in your career and become higher and higher into the design and analysis, you start getting into all these documents. For the time being, these are FYI only. You might, Brian, my friend, you might live and die and have a great career in the electrical industry and never touch any of these. You know, that's typically, you know, we do life safety training for 3M, so we have to go dig into that article and get the information and deliver it to 3M. So it go to the next level. If you're training the trainers, if you're getting to the next level, that's when you get there. Any comments, guys, about these standards? I want you to know there's other standards in the code that goes over these.
You have to test your generators at least once a year.
They exercise them, I thought, monthly for emergency. I thought monthly, emergency generator. So they go through the whole emergency generator testing. Hospitals, special hospitals. You don't want to leave a year? No, a year is way too long.
Another company I used to work for.
Is it yeah, it depends again, emergency or legally required or optional. Okay, now the cheapest piece of equipment for emergency that you guys can buy is Buckeyes. This is called, the code refers to it as self-contained battery powered unit. A big fat name for a Buckeye like this. It has a battery inside it, and it has a power. It has a power that's coming from the line side of the switch. The line side of the switch. So here's my light, and here's my emergency light. That's how this is my emergency Buckeyes, right? My Buckeyes, my battery. Can you guys see that? And these are in one room. These are all in one room. That's what you guys did with your friend Chad, right? You brought, from the line side of the switch, you brought branch circuit, extended branch circuit, and you fed a Buckeyes with batteries. So what happened, this is supposed to get you, I believe, 90 minutes, this battery. 90 minutes at, I can't remember, 84% of the rating, the light rating. So you lose power. So a troublemaker like Brian, can we pick on you, Brian? Do I have a choice here? So you want to use a 20 amp circuit and open that circuit breaker just to screw up with the kids, or like, for example, in hallways. To screw up, you want to open the circuit breaker. Guess what's going to happen? You're going to sense here, they're sensing the voltage right here, guys. They're sensing the volt to have lost. So what they do, then they have a transfer, a little tiny relay that talk that connect these to the lights, I don't know if you guys can see it, bring the power to the relay and the batteries. It since that the power has lost here, so flip these two to run them on a 24 volt. That's what this bug guys does. You're supposed to test them monthly because they're emergency system. So you go there, push them, push the button to test them, or there's remote testing and so forth. Any questions about this? That's the cheapest way of getting an emergency light in the building, using batteries instead of generator. Okay, so power demand, and so if this is a good way, if the power demand is low, for example, at Dunwoody here, we have them all across the hallways, stairways. That's all. We don't have them here in the rooms. So hallways and stairways are commonly major application. Bathrooms, major application for them. Any comments, guys? Any questions? And they let what? The egress path, your egress path. So they are connected to the normal power source. Can you guys see inside the box right here? What we do is, here's my switch box. That's exactly how we do it. And I'm only showing the neutral. The neutral is going to come also from here. I'm going to come with my neutral directly. If I have my neutral, comes in here and it goes to this light and also comes here and it goes all the way to that system. That's exactly how you connect your bug guys. Any question, guys, about this emergency bug guys? Piece of cake. Okay. We talked about the classification of the system. Legally required standby, or owner may choose to install an optional standby system. Wiring performance square, different types of systems. So we'll go over that one. Emergency system, this is where it tells you, very important, this is where if you are doing an emergency system, I can't emphasize emergency, you have to keep the wiring completely independent of any other wiring, not enter the same raceway box or cabinets, be kept entirely independent of all other wires. Can I have thumbs up, Chad? We fully understand?
The book says 700-10.
700-10. You probably, that's an old version. Can you guys check it? Yeah, thank you. 700-10. So could be coming from an old, not updated, but it will tell you in Article 700, guys. It'll tell you that the system have to be separated. Can I have thumbs up, Chad? We fully understand that one. Cool. So systems have to be separated. Here's how they allow you. Life safety does not allow you to do that. For emergency system, you can have bug eyes, check, done. Or you can have two services coming to your building, coming from two different substations. So this is my emergency service, and this is my regular service. That's allowed by the NEC code book, not by the life safety. Yeah, was it 1.10? There must be .10. Thank you. So so it will be 700.10. Okay. So for emergency system, guys, option number one to have batteries. Option number two to have another service coming to your building. Another service coming to your building. That life safety does not recognize this because if you have a storm, like, do you guys agree with me? If you have a storm, if these are knocked down, what's the likelihood that these are going to still standing, right? So, but in downtown Minneapolis and all this stuff, guys, because the grid is coming from underground, reliable, so they have two feeders coming to the building. So if you lose one feeder, highly unlikely you're going to lose the other feeder at the same time since you're underground. So that could qualify as one source of power for your emergency system. Okay, so for your emergency system, there's really, typically, here's what you're going to have. Number one is batteries. Number two is gen. Number three is another second service. These are one of the three options that you can have as source of power for your emergency system. The same thing for legally required standby system. By the way, the same thing for legally required standby system. You can have a battery. You can have a generator. I don't think they allow you to do another service as legally required standby system. Another service. Generator, typically generators. Wiring. Wiring for legally required standby system. These are the legally required standby system. They can occupy the same raceway boxes enclosures. No separation. No need to separate. Good idea to separate? Yes. Do you need to separate? No. Uh, they also allow you, I have a picture of that one, they allow you as a source a source of power to connect ahead of the service disconnect. I don't know if we have the picture here. Here you go. So this is my sump pump, sump pump, legally required standby sump pump. They allow you to connect it ahead of the service, and that considered reliable way of power for a legally required standby system. You don't need a generator even. Can you guys see that? Ahead of the service. This is the service coming to the whole building. They can allow you to tie ahead of it. Typically, this is for fire pumps, guys. Fire pumps are notoriously famous of that. If you have a fire pump, you are required to have a generator, or you are supposed to feed it from ahead of from ahead of the disconnect. This is my main disconnect. So if there's a fire in the building, the fire pump continue to run while the firefighters disconnect the power and de-energize the power system in the building, right? De-energize it, but the fire pump is still running. Again, fire pump is typical application of this. This is legally required standby system, no generator needed. All what you have to do is feed it ahead of time. A lot of government places, guys, when they have fire pumps out, how many apps they always connect it ahead, and they have a generator backup too. Have a generator backup, because you could lose the power here too, couldn't you? So they always have connected ahead of the service for fire pump and have a backup generator. Any comments, any questions? But this is an approved, another source of power for the legally required system, not the emergency. Not the emergency. So that's my emergency generator. So these are different ways. The generator, oops, it's jumping. Generators, engine type and fuel. When typically they do gas generators, we thought you guys have side generator with your friends as your emergency source of power. I can use a generator, one generator, or 3 generators to give me 3 systems. By the way, I have one gen here. I can bring that feeder into a box, and I can get 3 systems out of it. I can 1, 2, 3 systems. This will be emergency. This will be legally required emergency system, and this is standby. Out of the same generator, Jeff, I can get all these. I have to have an auto transfer switch though for each one of them, and then another source of power coming. I can, from one generator, guys, I can get 3 systems: emergency, legally required, and optional. Can I have thumbs up, Chad? We fully understand. One generator can cover us for all. Okay, with generator come engine. Engine, typically diesel engine is the most common. Type of fuel, you can have diesel or gas. If you have diesel or gas, you have to have a 24-hour tank by code, 24-hour gas reservoir of tank on the site for your generator to run. At least 24 hours. Cool? So what they do is they have a generator, and they sit right underneath the gen. There's a tank, a 24-hour tank. So they run you for 24 hours before you lose power for emergency.
You can use propane too, can't you?
Propane is another one. You can use any fuel for any engine. The problem with this generator, as engines driving a generator for emergency, whatever you use, you have to have a backup for it. So you have to have a propane tank. And how many people like to put it around propane tank? That becomes the issue. Or gas tank. That's why diesel is the most common, is because diesel you can throw it there. It's not that flammable. Cool. Any question, guys, about this? Which and some regulations, some cities don't allow you to use diesel. They want you to use natural gas and so forth. But the most common, guys, is diesel engine to drive emergency system. Illegally required standby system. Now the problem with optional standby system, if you have a generator classified as optional, the EPA will kick your butt because EPA cracks down on generators for pollution reasons. They don't want you to burn diesel and run your generator off the grid to save money. So most of the time, a lot of people, guys, like to classify their system as either immediately required or standby because they can get away with a lot of diesel burning versus if it's standby, I want to run my office here because I don't lose money. EPA would not buy this. Will force you to do a lot of to basically make using diesel so expensive for you that doesn't make financially reason doesn't make a reason financially to get off the grid and run diesel. So that's a big deal on that one. Cooling. When it comes the diesel, the generator guys, you guys are going to have a great presentation next week by Jerry Boggs from Kohler. He's going to talk about everything you need to know about generator. For the time being, when you have a generator, there's three major parts of a generator. There's the alternator, that's the gen. There's the engine, and there's the radiator. So there's a radiator like your car, right? The engine of your car, radiator to cool the engine, and engine to drive the generator and power coming out of it. Can I have thumbs up, Chad, about generators? There are three major parts. You have the engine that burns the fuel, like my car and yours, and there's the radiator that blows air or even pulls some liquid to cool the engine if it's a big engine. And of course, the engine is driving an alternator to generate power. And I'm going to allow Jerry Boggs, guys, is going to talk into details about the generators when it comes. Really, you're going to enjoy it. Okay, so you can cool them with air, typically a lot of air or liquid if they're a big system. Larger KW, you start using liquid to cool them. Almost all the emergency generators, Jeff, are like a meg and a half, less than a meg, 500, a meg, 2 megs. These little ones, you can cool them by air cooling. Radiators. And when you size a generator, the first thing we do is you have to pay attention to the voltage that you're sizing, right? Isn't that what we did when we sized with Cummins, guys? The first thing you picked is what? Gen. What type of voltage you're going to do? So that's also your generator voltage must match your building voltage. Can I have thumbs up, Chad? We fully understand that? Cool. Okay, capacity. When you size your generator, my friends, there are two important things, like you guys have done it with me. I feel comfortable with that one. Number one, starting kVA, starting volt amp of the generator, and with where's the important? Okay, for to determine the correct side of the generator, starting kVA for the motors. When you have the starting kVA of the motor, guys, you use the locked rotor current. That's how the starting kVA for motors. In the software, Kerry, when you guys use the software with Chad, do you remember when we were picking horsepower and we were picking the starting mechanism? How do you start it across the line, the worst, or VFD, the best? And then when you went to the last slide, it tells you what the locked rotor current or the code letter. What code letter do you want to change it? The code letter will decide the starting capability of this generator. So they add them up, all the locked rotor current, kVA of all the motors, and the running kVA, and they pick a generator that can run this amount of power and start this amount of power. Cool? Can you have thumbs up, Chad? We know when we size generator, that generators have to be sized based on the starting load and the running load. Cool? Everybody understand that one? You guys have done it with comments. Starting load. Maximum kVA, continuous. So we have the starting load, and the second part is you have the continuous load that you need, the running load. The running load. Okay, so we have two. They have the running load and the starting capability of the motor. Now, Aaron, when you guys were designing with your friend Chad, do you remember how you put them in steps? Do you understand what a step says? Steps means start them gradually, not at the same time, because starting them at the same time will give you have to have a huge generator to be able to have oomph enough to start everything from nothing, they're not running. But if you start them one at a time, I start you, you're up and running, now you're running, now I'm unstable, start you, up and running, 10 seconds, unstable, one at a time, it makes the size of your generator smaller. And you guys can go try the software that we have. So when you size generators, running load, no problem. That's the volt amp of your loads. Starting load, you have to find the kVA, the locked rotor current or the starting current multiplied by kVA. But when you start them though, the key point is not to start them at the same time. Can I get you guys get this message? Not to start them at the same time. Okay, so that's my capacity. Okay, derangement signals, emergency generator, legally required standby generator require an annunciating panel. Does that ring a bell, Joe? It's like the annunciating panel that you guys have, annunciating panel. This annunciating panel has to have audible and visual, so people can hear and see it. It's if this is the generator here, it has to be set outside. The alarms have to be set outside. So if there is if the battery in the generator is shot, it should alarm, visual and audible. If the auto transfer switch for the emergency system is not working, it should alarm. If it's low in fuel, low on oil, what else? Fuel, oil, dampers are not opening. Anything that could jeopardize the operation of the emergency system must be announced before you need that emergency generator. Brian, the worst thing that could happen, you have in the hospital and you lose power and the auto transfer switch sends the signal to your generator and your generator sits there and oops, the battery, the starting battery for the engine is dead, right? It's not like happened to our cars. Your battery is dead on your engine. That's why you have to announce all these. Installed outside the generator room so people can literally see it. You have to be dumber than rock that look at that thing flashing and making noises. Go to the generator room, fix the problem before you need it. These are guys at all times monitoring the system. At all times. So what does it do? It malfunctioning of generator units, load in the system, correct operation and battery and so forth. So anything that has to do with the generator, proper operation, if there's malfunction in it, Jeff, has to be alarmed outside. Low oil, low fuel, low battery, any of these systems, hot, too hot in the room, temperature in the room, too cold, the alarm, a bunch of other things. Next week, guys, after you eat the turkey and you come back, Jerry Boggs is going to talk a lot about the annunciator. They call it generator annunciator panel. They put it outside. Any comments, any questions about that one? Required for legally required standby system as well as emergency. Legally required and emergency. How about the optional? Option is optional, but they always do it anyway. Okay, derangement signals. Any question about derangement signals? Darren, if you have a ground fault in the generator, also have to be alarmed. You have a ground fault in your generator, it has to alarm that you have a ground fault before you ask your gen to pick up the load. Do you guys understand how important the emergency generator? Somebody's chest is open. You want to call on this one, that has to run. And Jerry will tell you, generators, they have jacket heaters. They heat them. They keep them warm at all times. By first put them in a room that's that warm room temperature. Second, by have a jacket heaters, they heat the engine. The engine is ready to go. Because if you leave the engine sitting outside for a month without being warm, what's going to happen? It's not going to start. Like your car in the winter, what do we do with the car if it's outside? You plug it. So they keep these emergency generators and legally required standby generators warm by design. So you have a circuit, 20 amp circuit, sitting and heating the engine, keeping it. There's a place, a heater there just to keep the engine warm, ready to go. Ready to go. Okay. All right. So that's all about the generator, guys. The second thing I'm going to talk about here is the auto transfer switches. Requirement to be connected. We'll talk about the position of the auto transfer switch. We talked about auto and manual. They don't list the static here because the static typically used with data centers, static, but typically your auto or manual. Typically the auto transfer switch is connected in the load side of the disconnect means. The load side of the disconnect means. We'll look at a couple of pictures in this case. So, main power source fails, equipment must be provided to. Auto transfer switch, my friends. So here's my auto transfer switch. Here's my utility, my gen, my utility like you guys did. Here's my emergency panel. Within 10 seconds, if I lose my utility, the auto transfer switch should start, since that power lost, start my generator, send a signal to the gen to say, hey, by the way, start. and transfer me to my generator load as an emergency load. Legally required standby system, 60 seconds. Does that make sense? So start the engine, transfer the load. So you have a control panel that comes with it, obviously, and that control system is monitoring the line coming from the utility. If the line is lost, bam, it slams you onto the generator, start the generator and slam you back into the gen. Any comments, any questions about the auto transfer switch? Any questions, any comments? So that's my auto transfer switch, my friends. Wiring, branch circuit. So we talked about wiring for emergency system. They have to be the keyword separated. So can I hear the word separated? Separated for emergency system only. Legally required and optional, up to you. Okay, here's an emergency circuit, guys, that they have. They're separating them. I don't know if you can see. They're separated between. They're coming to the same box. Can you guys see that there's a switch tool? They're separating them. They are keyed switch. They use keyed switch on them, where you can turn them on with a key, and they're sitting right in here, separated from any other system. Cool? Separated from any other system. Wiring from normal and emergency source permitted by some applications. So here's a fixture where you can have, sometimes right into the fixture, guys, right down to the fixture, you can have a circuit, a branch circuit. Here's a 20 amp and another 20 amp here, 20 amp here. This is emergency, this is normal. So look at this. This is the same fixture that's sitting above your head. You're using it, and there's a relay here. You're using it, guys, to feed, to turn it on and off, like any other fixture. You know, so I'm using it to turn it on and off. Where's my on and off here? I'm turning it on and off here. And at the same time, if I lose the emergency system, the normal power here, there's a sensor here that senses that the power have lost and switch me to this circuit. Now this power will go on by itself because it recognized that we have a loss of power. We didn't use this system in this building, in the building that I have. Next project, mark your words, Joe, my friend, in the spring, you're going to be using a system like this. We have an emergency panel here and a normal panel, and you're going to have two circuits coming to the lighting fixture, one from the emergency, one from the normal. Any comments, guys? Any questions about this system? That's coming in where? In the spring. If you know it now, you're ahead of the curve. If you have a UPS system, guys, uninterruptible power supply for data centers, if you have a UPS system, when I was doing data centers, guys, they used to tell us if your UPS is 1,000 kVA, the generator to pick it up have to be 2,000, twice. UPS have harmonics, and harmonics affect the operation of generators. So when you have when you pick a harmonic load, heavy harmonic load like UPS system that takes AC, convert it to DC, invert it back to AC, dump it across the data center for the financial transaction for Home Depot around the holidays. Imagine Black Friday is coming, right? So imagine how important that is. You have UPS backup 100%, no interruption of power. So if you're to back up a UPS system, we'll talk more about this one. There's nonlinear loads, and these nonlinear loads create problems for the generator. So now, typically, I think it's 50% extra. So if you have 1,000 kVA worth of UPS load, computer load for your transaction, you size 1,500 kVA generator to pick it up. Add 50% to accommodate for the nonlinear load. And again, the softwares that we have also take into consideration the nonlinear load. Okay, so that's basically it, guys. Any comments, any questions before I show you a couple of pictures here and I'll let you go. I'm going to show you one or two picture here. Okay, you guys want a quick break? Yes, no? I have a couple of pictures I'm going to show you and then I'll let you go. Okay, so here's it's really not a whole lot. I need just 2 minutes here. Here's a second source of power. We talked about these two. Second source of power. This is important, guys. This one is important. Oops. This is how they do. This is typically how we do an emergency system. You bring the service. Can you guys see the services coming in here? fuse disconnect, and then we bring it. Isn't that, Kerry, what we did for our building? We brought to the service, but in our building, these two were in one box. These two were in the auto transfer switch with a service disconnect means in one box. We brought the service into the auto transfer switch, and then we back up generator, and we put our 500 amp panel here, and this was a 500 amp, and this was a 500 amp fuse, and this was a 600 amp disconnect. This is exactly what we did in our building. The auto transfer switch that we order, guys, has to have a disconnect, a fuse disconnect or circuit breaker ahead of it. Any question, guys, about this connection? That's what, if you will back up the whole building, how you do it. Okay. Let me erase that one here. That's my building. Let's go to another application, which is backup generator. This one, this one is a service rated. You can bring it directly to the auto transfer switch. You have to have an off position because that's your disconnect. And you also have to have an overcome protection device, somehow an overcome protection device. That's another way of doing it. I don't know if you guys can see the off position here, right into this switch gear. This is the typical way of doing it, guys, is that's what we did. You bring an auto transfer switch, 500 amp, 500 amp auto transfer switch, 500 amp disconnect inside it, and you feed the whole building, which is my building was 500 amp. And from this building, if you guys remember, we fed a 200 amp and another 100 amp or so for receptacles and lighting panels. That's exactly what we did. This is exactly what you guys did with us. Any comments, any questions about that? Typically what we did. Remember how we said the main panel has main lugs only? Because why? Circuit breaker is sitting inside the box that has the auto transfer switch. Then bonding and grounding happen right here. So ground and neutral, so you bond here and you bring the neutral right here. So that's your disconnect means right ahead of the transfer switch, ahead of the transfer switch, ahead of your transfer switch. Okay, so that's, I wanted to show you that one. A couple of pictures about emergency system, separate. I don't know if you guys can see how the two systems are separated here from each other. Bug eyes, everybody familiar with the bug eyes? You guys have installed them, seen them. Generator enclosures, different generator enclosures. Here's the annunciating panel. This is the one that has to be out, has to announce if you have any issues, and the alarm have to be outside. Alarm on overload or whatever. Transfer switch, guts of the transfer switch. Keyed switches for emergency light, you can key them on and leave them on. And then if you want to tear them off, you can tear them off. Two circuits coming to a lighting fixture, one from the emergency, one from the panel. That's also the typical. Okay, so let's go here, here. This one, guys, really nice summary comparing between the three systems: legally required, standby, and optional. For example, rules apply only for legally required. Yes, yes, no. Equipment approved for legally has to be must for legally required according to the authority. For emergency, yes. Restoration of power 10 seconds, 60 seconds, whenever. Transfer switch auto, manual or auto. Priority very high, second lowest. Can you guys see that? This is one of the best table that summarizes. Permitted to supply other loads, emergency, yes, and standby and optional, all of them. Circuits, separation, isolation, yes, no, no. Connection ahead of the ahead of the disconnect, no, no. You have yes for the legally required standby system. Separation at the service. So there's a lot of installation and testing, yes, yes, for the two signals. Here's my favorite. Signals, yes, for both of them you have to have signal. Not required for the optional. And ground fault, yes, actually this should be changed into no, Aaron, my friend. They also now they require them in the ground fault protection, annunciators, indicator on both the emergency and legally required. So this is very nice sheet, guys, that summarize the three systems together. Here's how you calculate the lock torque for the motor. So if your design is D, remember using this table, you take the highest 4.49, multiply it by 1,000 horsepower. That will give you the lock torque current for the kVA for this motor. If your motor, guys, is say 100, multiply 4.49 by 100, that will give you 449 kVA, done. That's how much the generator has to pick as a starting capability. This is directly from the code. If your motors are small, they give you these are peanuts ones. They give you these values to add. Auto transfer switch for hospitals, it has to be auto. Emergency system for emergency auto or manual for option, and in a critical operation auto. These are the systems that we talked about and which type of auto transfer switch required by code. All of them required an auto except the optional. Chad's backyard generator, whenever you finish lunch with the kids. Any questions, any comments, my friend? That's all. I know it's the day before Thanksgiving and your mind is not fully with your friend Chad. But I hope if you guys understand this, you are more than a drafter. This will elevate your knowledge to the next level. Any comments, any questions? Please read this one next week when Jerry Boggs show up and talk about generators and auto transfer switch. I hope this will get you enough juice to get the stuff up and running. Okay, that's all I have for you. Thank you.